Okay, welcome back, everybody. Now, we're finished with the internal and external water treatment stuff. There'll be a quiz this weekend on the internal water treatment. And so that really means that we're on the next topic, and this is probably going to drive you a little crazy because this is about baking a cake, and you're wondering, what is this guy doing? This is utter nonsense. Why is he wasting our time? This is power engineering, for crying out loud. Cakes are not the next topic. Well, I can assure you that cakes are the next topic. Okay, you just don't realize it yet. So, here's a question for you folks. Throwing it out there, what makes a good cake?
Baking soda.
Oh, now you're going into ingredients. Okay, you know what? Put the recipe over here. Okay. Oops. Recipe. Okay, so we'll put baking soda over here. Okay, that's the actual recipe. But what I mean is, when you're eating a cake and you go, oh, what a good cake. I mean, you don't bite into a cake and go, oh, the baking soda is amazing.
It's got to be fluffy.
Oh, there's a good one. I like that one. Fluffy. There's nothing worse than a cake that's like as heavy as a rock. Okay? Nice and fluffy. What else?
Smell and texture.
Texture. Okay, that's a good one. And what was the other word you said? Smell?
Yes.
That's an interesting one. I didn't think of that. What else do we have for a good cake?
Moist.
Moist. Oh, yeah. I can almost taste it. Fluffy and moist. And maybe that's kind of the texture too. It's moist and fluffy. Anything else? Well, that's probably enough. Let's, for the sake of this discussion, we're going to say that a good, why is it doing that? That a good cake is fluffy and moist. Fluffy and moist. Okay, and that's what we're going for. So let's work on the recipe then. So we're going to need baking soda. What else do we need for our recipe to make a fluffy and moist cake?
Egg, flour, sugar.
Flour, egg, sugar, you said?
Yes.
What else do we need?
Oil.
Butter.
Oil. There's a good one. Come on, you cake baking guys. Gotta be some more.
Vanilla or cacao, maybe.
Okay, cocoa, hey? You make a chocolate cake, or maybe vanilla. Okay, I got a bowl. I'm gonna put some baking soda, some flour, an egg, some oil, cocoa, vanilla. What else am I gonna put in the bowl? I'm gonna mix it up.
Milk.
Or something more common than milk might be water. How about that? You're not gonna get very moist without any moisture in it. Okay, so, these are our ingredients. What else do we do? So after we mix it all up, we in the right proportions, then what do? We got to bake it, right? So what else? In terms of baking, what do we got to do to bake this cake?
It goes into preheated oven.
Okay, give me a temperature.
350.
350. Celsius or Fahrenheit?
Fahrenheit.
I could do Celsius. Okay, preheat in the, okay, we put it in the oven. And then what?
Set the timer.
Okay. For how long?
Half an hour.
30 minutes. Okay. All right, so here we go. We're going to bake a fluffy and moist cake. And we got all these various ingredients. And I'm really surprised by one thing that people didn't say was there's fluffy, texture, smell. How about taste? Do you like a cake that tastes good? Most people do. I'll take that for granted. But our goal here is fluffy and moist. Okay, our goal is fluffy and moist first and foremost, because it doesn't matter what it tastes like. If it's not fluffy and moist, it's a no good cake. So what we have here are a bunch of variables. So for example, and even down here we got variables too, right? And some of these things are absolutely essential. So for example, how about the oven temperature? Would we call that essential? Essential is going to mean anything that is absolutely necessary for making fluffy and moist. Do you think that's essential, 350 degrees Fahrenheit? What if I decide to do it at 450 Fahrenheit? Or if I do it, 150 degrees Fahrenheit?
So if we change the amount of variables like the ingredients, maybe we can change the temperature.
Okay, all right. But let's say that we don't change any of the ingredients, but we change the temperature up to 450.
Change the time it's in the oven.
Oh, okay. So you know what? If we only don't even change the time in the oven, but just change the temperature to 450 and leave it in there for 30 minutes. What do we get? Fluffy and moist?
Probably it's not going to be the same.
Let's say we leave it at 350, but we put it in there for 90 minutes. What if we change this and said, we're not going to put it in there for 30 minutes. We're going to put it there for an hour and a half in the oven at 350. We're going to get fluffy and moist?
You may get fluffy.
It might be fluffy and dry. It might go on fire. Okay. So here's the whole idea of an essential variable. Anything that's essential for making a fluffy and moist cake, we're going to call it an essential variable. So baking soda. Maybe the recipe says I need 1 tablespoon. What if I skip it out? What if I don't put any baking soda in there at all? And I don't know what's going on here with my mouse, but it's driving me crazy here.
They don't have a brownie.
Brownie won't be a fluffy cake, right? What if I say, instead of putting half a cup of water, I'm going to put 3 cups of water. Maybe I'll get soup. I don't know. So let's go over each one of these and see if they are necessary for fluffy and moist. Baking soda. Necessary for fluffy and moist, yes or no? Okay. Flour. If I change how much flour in it, if I put too much or too little flour, is it going to be fluffy and moist?
No.
Okay, so that's also essential, right? That's another essential variable in our cake recipe. What about egg? What if we forget to put the egg in it? It's probably an essential variable too. Essential, essential, essential. Sugar? Is that an essential variable for making it fluffy and moist?
No.
Maybe not. Maybe all that is going to do is help us out with the taste, make it tasty, okay? But it doesn't make it fluffy and moist. Oil, fluffy and moist? I think so. I'd call that essential. What about cocoa or vanilla? Are these essential? Can I skip it or add extra without affecting the fluffiness or moistness of the cake?
It's not essential.
Not essential. Not essential. And then milk, water, probably these are essential. So what we have are essential variables and non-essential variables. So now let's compare this to the world of welding. Welding also has essential and non-essential variables. And so what we're going to do is refer to ASME section 9. And ASME 9 is kind of like ASME 2 in that it supports the other codes. So for example, in ASME 1, it'll say, I'm going to make a boiler. Your joints of the boiler, the weld joint must be in accordance with ASME code section 9. Okay, so that's where section 9 comes in. And so for cakes, we've got these essential variables: flour, water, egg, etc., baking soda. And for welding, we've also got essential variables as well. So for example, what kind of welding process are we using? The word process means, are we doing shielded metal arc welding, which some people call stick welding? Are we doing gas tungsten arc welding? Are we doing gas metal arc welding? Are we doing submerged arc welding? So these are all processes, and they're considered to be essential variables. So what I'm going to do is I'm going to write a weld procedure specification. For a cake, what we had was a recipe, and for welding, we've got a weld procedure specification. A weld procedure specification is basically a recipe for a weld. Just like the cake recipe, there are certain things that are fundamental for making a fluffy and moist weld. But in this case, we don't want the weld to be fluffy and moist. What we want it to be is ductile. We don't want it to be brittle. And the other thing we want is for it to be as strong as the base metal. So ductile and strong. So the process that we're going to use is going to be one of the important things about a weld procedure specification. So the cake process might be, oh, I'm going to do it in a toaster oven, or maybe I'm going to do it in a regular oven, or maybe I'm going to bake the cake in a microwave oven. I think there are microwave cake recipes. So that would be sort of the process. Whereas in welding, we've got shielded metal arc welding, gas tungsten. So you can see how the type of process we choose for doing the welding is going to affect the weld procedure. Okay, because you're not going to have the same variables if you're doing submerged arc welding compared to oxy-fuel welding. Is current. So if it is an arc welding process, and really that's all that we're concerned about right now, we're not going to worry about oxy-fuel welding or laser beam welding or anything like that. Really we're talking about arc welding. And arc welding gets the heat from the heat of the arc, which is quite intense. So current, we know that power is equal to I squared R. So obviously the amount of current is going to affect the amount of heat that is produced. And so if we've got very thick metal, we're going to need more heat, which means more current. Just like a recipe is going to say the oven temperature, okay, our weld procedure say how much current we're using. Then the other thing about current is it going to be AC, alternating current, or is it going to be DC current? And if it's DC current, we're going to have an electrode. Is the electrode going to be positive or is the electrode going to be negative? So we have two types of DC. We've got DC electrode negative, and we've got DC electrode positive. So this is also going to be stipulated on our weld procedure. Is it AC? Is it DC? And if it's DC, is the electrode negative or is the electrode positive? So DC electrode negative has a slang term, and the slang term is straight. And you'll still hear welders using the word straight. And DC electrode positive is what we call reverse polarity. Or welders just say the word reverse. Now, what else do we have in our weld procedure specification? It's going to be the type of parent material. And so, we can have low carbon steel or mild steel like we see with boilers. We can have, stainless steel. We can have medium carbon steel, high carbon steel, have titanium, all kinds of different parent materials. And if we are doing this electric arc welding with a filler material, we can have various types of filler rods. And actually, I shouldn't say rods, because a rod is a fairly short piece of metal. We can have a continuous roll of filler metal that's automatically added. So we can have various filler materials. And so this would be rated according to their chemistry. Low, mild carbon steel, high carbon steel, whatever, alloying agents, and also the strength of the filler material. So generally speaking, a weld procedure specification is going to say that we've got a particular material that we're joining to another material, and the filler material is this, and so each one of those three materials is going to be identified in the weld procedure specification. The next thing, we'll have a joint type. Will also be in a weld procedure specification. So we might have a groove weld. We might have a fillet weld. So the groove weld, it's going to be what kind of groove? Is it going to be a V groove? Is it going to be a U groove? Is it going to be a J groove? All these various types of weld joint preparation. And is there going to be backing? Again, this is all going to be specified on a weld procedure specification. So you can see here is a little diagram of a groove joint, and it's got particular joint preparation in the form of a V. So what they've done is they've taken both pieces of metal and they've ground them so that we get a particular angle, and so then what they're going to do is weld it. And so the first pass is going to be down there, and what we want to get is full penetration. And by full penetration, what we mean is that the weld material penetrates through the whole thickness of the parent material. Now, some people call it the base material, but I like to use the word parent material because that's what ASME is. We call it the parent material. Parent meaning it donates some of its metal to the final weld. So the first pass that goes in is called the root. And we might have a backing plate. And if we've got a backing plate, then the weld procedure specification has to say, oh yeah, there's going to be a backing plate behind the weld. If there's no backing permitted, it'll say on weld procedure specification, no backing permitted. Then what we're going to have is, subsequent passes to complete the weld. And so usually what we have in a weld procedure specification is a diagram of the weld. Weld procedure specification is also going to have to say not only what type of material we're welding, but it's going to have something about the thickness range usually. So add it over here. With the thickness range, we find that there are different kind of requirements to making a ductile and strong weld. Depends upon how thick the material is. So very, very thin material is going to require a little bit of heat, and it's going to have to require a lot of skill so that you just don't burn holes through the parent material. Okay, so if we're just making a weld on a thin piece of material, a lot of skill is involved in that. But if we're welding really thick material, then some other techniques are going to come in play. We're going to be depositing a lot of material, and whenever we do that, we're going to possibly have distortion in the parent material. And we'll talk about that a little bit later. But so basically, things are going to get pulled out of alignment, things are going to get stressed, and so there are certain welding techniques that are done to prevent things from distorting and all that kind of stuff. So different techniques depending upon the thickness of the parent material. So there will be a thickness range that is identified on this weld procedure specification that says that if you are using this recipe, if you will, you can only use it for metal that's, say, 1 millimeter to 6 millimeters thick, something like that. Okay, there will be a thickness range specified on a weld procedure specification. Now, sometimes we've got a procedure specifically for welding pipe. So in addition to all of these things, we'll see things like pipe diameter. Again, there will be a range. And what we find that if somebody is welding pipe, it's very difficult to weld a small diameter pipe than it is to weld a large diameter pipe. So small diameter pipe, I've got to somehow get all the way around that pipe. It's hard to work around such a very small pipe. But if it's a big pipe that I'm welding, it's much easier to weld. It's hard for me to explain, but maybe it's a little bit easier for you to visualize that a large pipe is easier to weld than a small pipe. So, to kind of sum this up, a weld procedure specification is a recipe for making a weld. And in that weld procedure specification, there are certain variables that are essential and certain variables that are non-essential. The essential variables are the things that we've listed here: process, current, thickness range, diameter, parent material chemistry, filler rods, type of joint preparation, that type of stuff, okay? What it means is if I change one of those things, it can change other things. Just like I was saying, hey, what if we went and took the cake oven temperature up to 450? And somebody says, well, then we have to lower the cooking time. Okay. And they said, well, what if you didn't lower the cooking time? Oh, you set the thing on fire, right? Or, what if you didn't put any egg in it? Well, maybe there are cake recipes where there are no eggs permitted. Maybe people who have got egg allergies or something like that, and you're making a recipe for people who've got egg allergies. Then maybe you could make a different recipe that doesn't have eggs. Or in this day and age, people have celiac disease, or they're gluten intolerant, and so you can't make a cake using flour, so you have to use some other different kind of flour. You can't use wheat flour. Well, then you'd have a different recipe that uses a different kind of flour so that you could make a cake that's gluten-free. Same with welding. If I change any of these things, if I change the current range, if I change the thickness range, if I change the parent material composition, if I change the type of filler material, if I change the type of joint preparation, that's fine. I'll still be able to make a decent weld, but what I need then is a new procedure. I need a new recipe because the old recipe doesn't qualify anymore. Does that make sense? With a weld procedure specification, what it does is it lists all variables, and the welder has to follow it, because if you don't follow the procedure, you're going to get a lousy weld. Okay, I mean, what's the sense in having a cake recipe if you don't follow it? You know, you got a cake recipe, but I'm going to put it in the oven for 8 hours at 800 degrees Celsius. You're going to make a hockey puck or a fire. You're not going to make a cake, right? So you need to follow the recipe. Same with a welder. Welders have to follow a weld procedure specification. If they don't follow the welder specification, make a lousy weld. And I should mention, lousy welds are dangerous. So if you got a bad weld on a boiler and the boiler's under pressure and the weld lets go, people die. So the weld procedure lists all variables. Welder must follow the weld procedure. Right, so if a variable is changed, and say an essential variable change, means that we need a new procedure. Just like we saw with the cake, if I decide to use a different type of flour, then I need a new recipe. Okay, so now the next thing is evidence. How do I know the weld procedure is going to make a decent weld? Well, let's think about this. Let's go back to our cake, and let's say that I have a bakery, and the bakery, the bake shop owner makes their own recipes, okay? And this bake shop owner gets an idea, for a new type of cake that's going to be so fluffy and so moist, and people are going to be dying for this cake. So imagine a world where if you come up with a new cake recipe, you have to get it inspected by a third-party inspector. So if you can imagine, let's say, the Great Canadian Bake Off or the Great UK Bake Off, whatever, and so these bakers, they come and they bake their cakes and they bring it to this Great Canadian Bake Off. I don't know if anybody's seen this type of show on television. And so then this third-party inspector comes along and they taste all of the different cakes and they say, well, this one here is nice and fluffy and moist, and that's the winner, right? So if you can imagine a world where if you have a cake recipe, you cannot actually bake that cake until you've proven that it's a good recipe. So here I'm the owner of the bake shop, and what I have is a new recipe, and I think it's going to be a great recipe, but I don't know for sure. And I'm going to look for third-party validation. And this third-party validation is going to give me evidence that says, yeah, that cake is a nice and fluffy, moist cake. So what I need to do is get my best baker to bake the cake. I don't want to get this new baker to bake the cake because the new baker isn't really experienced very much and hasn't, been around the kitchen long enough, and I'm not really confident in this baker's skills. And what I want to do is make sure that I'm evaluating the recipe and not the skill of the baker. Okay, I want to evaluate the recipe, not the baker. So what I do is I pick the best baker that I have, and I send them off to the Great Canadian Cook-Off. And in the Great Canadian Bake-Off, this baker makes the cake, and it's moist, and it's and it's fluffy, And so then the judge along and says, yes, that's a good, moist, fluffy cake. Great, my recipe is a success, and now I can start to bake those cakes and offer them in my bake shop for the public to purchase it. But the public wants some kind of evidence. So what happened was, at the Great Canadian Bake Off, the judge put their name down on a piece of paper, and they signed it, and they noted the date, so it happened on November the 16th, 2020, and they watched that the baker was following the recipe. The baker wasn't cheating. The baker wasn't saying, I know that if I add a little bit more water, this cake is going to be better. No, the judge stands there and says, it says you add 1 cup of water, and that's all that guy's permitted to add, is 1 cup of water. So the judge is invigilating the baking and making sure that the baker follows the recipe. And so the invigilator, the judge, writes down the baker's name and writes down all of the various essential variables, oven temperature, time in the oven, all this kind of stuff, and validates that everything was followed to a T. And then what they did was they cake out of the oven, and they subjected non-destructive testing. They gave it a tensile test, they gave it a face bend or root bend, they gave it radiograph. No, they didn't do any of this stuff, but they do this with welds, okay? Anyway, so the judge says validates that it's fluffy and moist, and so there's a document, and this document is evidence, and this document that is evidence that the recipe is cross-references the actual recipe. So we call this a procedure qualification record, and a PQR then supports the weld procedure specification. So what happens in the world of welding, we have an owner of a weld procedure specification, and the owner of the weld procedure specification has paid big money to a metallurgical engineer to design this thing, or a weld engineer. And a weld engineer is somebody who knows metallurgy, who knows strength of materials, who knows chemistry, who knows joint design, understands stress analysis of weld joints and things like that. So the weld procedure is designed by an engineer. Now, I work for Tommy's Welding, and Tommy's Welding, I'm Tommy, okay, and I paid money to this engineer to come up with this weld procedure, and so I've paid for this, I own it. So Tommy, in this case, owns the weld procedure because he paid for it. So Tommy is going to take me, Tommy, I'm going to take my best welder, and I'm going to send them off to the weld test center that's run by ABSA. And there's certain weld test centers. I think that there are sort of third-party testing centers around the province where a welder, and I'm going to pick the best welder that I got, the most experienced welder, because what I want to do is prove that the weld procedure is good. I don't want to prove that my welder's a lousy welder. I want to take the welder out of the picture. So I take my best welder, send them off to the weld test center, and the examiner there is going to watch that this welder follows the procedure exactly and does not deviate from it. So it's going to say that there's a particular thickness. It's going to say that this is the current range. It's going to say that this is DC electrode negative or DC electrode positive. It's going to say that I'm using this type of weld electrode. It's going to say I'm going to weld in this position, whatever. And the examiner is going to make sure that the welder follows all of that stuff. Then after the weld is complete, the weld examiner is going to take this weld, this completed weld, and is going to cut it up into coupons. And this is not a coupon like you use at the store when you want 50% off of your bag of potato chips. This is a different use of the word coupon, and a coupon is just a sample that's being used for testing. And then what this tester is going to do is they may have their equipment in-house, or they may send it to a third-party inspector. But if they do it in-house, they're going to take that weld coupon. And so then there's the weld joint. And what they're going to do is they're going to do what's called a guided bend test. And so they're going to basically apply force, and they're going to bend it around a mandrel right on the weld joint. And what's going to happen is it's going to elongate along the outside edge, and so they're going to be testing for ductility. So they're going to do a couple of these guided bend tests. Guided bend. And probably also do a tensile test, and they'll probably also do radiographic testing. And they're looking for defects and flaws. They're looking to see that it's as strong as the parent material with the tensile test. They're going to see that the weld material, the resulting weld is nice and ductile, that is not brittle, and all that kind of stuff. So when this test results come back, they document everything. They document the weld name, time, date, time, date of test, current range, process that was followed, test results of the guided bend, of the tensile test, of all of this kind of stuff. And basically, does the weld pass or does it not pass? And if the weld passed all of these tests, name of examiner. If the weld passes, we end with what's called a procedure qualification record. So a procedure qualification record is tied to a weld procedure specification. Remember, we have not tested a welder. We have not tested a baker. Okay, we have tested a recipe. We've tested a weld procedure specification. And the weld turned out to be a good, ductile, strong weld. So the evidence is the procedure qualification record, or we call it a PQR. And I should let you know that all of this stuff is in ASME code 79. But it's also in so many other codes. So for example, American Welding Society has all of this stuff as well. That probably ASME adopted most of the AWS stuff for procedure qualifications and weld procedure specifications. Okay, so to summarize what we've done so far is we've got a weld procedure specification, which is our recipe that includes essential and even non-essential variables for making a good quality weld. And we have to prove that it actually produces a strong and ductile weld. In order to do that, we have to go to a testing center. We're going to get a very good welder to actually perform the weld. And then that weld is subject to a number of destructive and non-destructive tests as evidence that it makes a strong and ductile weld. And this is kept on file as a procedure qualification record, and what we will do is actually staple the two together. And the weld procedure specification might have a number. Maybe it's Tommy's number is WP 3001, and the PQR will say on it for WPS 3001. So they cross-reference each other. So there's no question about what the procedure qualification is qualifying. So the way that it works is that the hotshot welder, this top welder, is immediately qualified to do that weld. Why? Because the top welder, the one who went to the weld test center, demonstrated his or her ability to make a top quality weld. Not only demonstrated the quality of the weld, but demonstrated their own ability to do the weld. So the top welder here immediately gets certified. Which brings us to the next thing, is welder performance qualification. What we've done so far is procedure qualification. And procedure qualification, you get an engineer. Well, first of all, you have to have a need for it, right? So let's say that I'm Tommy's Welding and somebody comes up to me and says, I got this titanium and I need to weld this carbon steel nozzle onto this titanium. Can you come up with a weld procedure? So Tommy says, yeah, sure, we'll come up with a weld procedure, and contacts the engineer that works for Tommy's Welding. And the engineer works real hard and says, okay, you need this type of filler material. You need to use the best process for doing this is going to be GTAW. And so it's going to be a fully manual process. And, you know, based upon these thicknesses of the nozzle and of the plate, then you're going to have to, you know, use this amount of current and best to use blah, 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 right? It's all this type of things that the engineer considers in designing the weld procedure. And then the weld procedure comes back from the engineer, and then I take my best welder, Suzanne. And Suzanne, by the way, women tend to be excellent welders because they have very good control, better fine motor control than men. So I send Suzanne off to the weld test center, and she does the test, and they cut it up into coupons, and they pull it, and they twist it, and they turn it, and they do NDE and whatever. And it turns out to be ductile and strong, so we get a PQR that supports it. Now Suzanne is automatically qualified to do that particular test, or that particular weld going ahead in the future. So the next thing is we're going to talk about is performance. So I'm going to erase this. So now the next thing is welder performance qualification. So, you know, lots of welders, you talk to a welder, and the welder, yeah, I got all my pressure tickets. All your pressure tickets? You got all of them. Well, let me see. Last time I checked, there are, you know, 1 million different materials out there. And there's, you know, 4 different weld positions. There's, you know, 100,000 different thicknesses. There's, you know, 1,000 different types of joints, and combinations of backing and not backing and all this kind of stuff. And so you are going to tell me as a welder that you are qualified to do 4.3 times 10 to the 87 possible combinations and permutations of different materials and different positions and all this kind of stuff. You get to me that you're qualified to do every single one of those welds. What it really means is it's BS. Welders weld to a specific weld procedure specification. So a pressure welder may weld to what's called, now this is the bread and butter one, a P1 to P1, F3, F4, 2G, 5G, 6G, and test on a NPS for Schedule 80 pipe. And then you're going, what on earth does that mean? This is a very, very common weld ticket. Okay, this is a license. So what we're going to do is we're going to send a welder into the weld test center to prove that he or she can do this weld correctly. A P1 material, if you recall from ASME 2D, is a mild carbon steel. And so mild carbon steel behaves a certain way, no matter whether it's SA53 pipe or SA106 pipe or whatever. If it's a mild carbon steel and it's categorized as a P1 material, this welder, if successful, can weld on any P1 pipe. F3 refers to the welding electrode. So F3 refers to shielded metal arc welding. And you don't have to know this by heart. What you need to know is the principles involved here, okay? F3 is an SMAW, shielded metal arc welding electrode, E6010 electrode. That's an F3 weld. An F4 weld is shielded metal arc welding, E7018 electrode. 2G, 5G, and 6G refers to a weld position. So if I am welding a groove weld, it's given a G. If I'm welding a fillet weld, it's given an F. So I could have 2F, 5F, 6F, but I don't. I've got 2G, 5G, 6G. So these refer to the positions. And so a welder can weld in the flat, can weld in the horizontal, can weld in the vertical position, and can weld overhead. Of these, which do you figure is the hardest? Okay, the toughest one is the overhead. The easiest one is in the flat position. And so 2G means horizontal. The vertical position is 5. And if I have a 2G position and I have a 5G position, that is the same as an all-position weld. So 2G, 5G gives me all positions. So what I'm going to say then is the welder is going to test for doing a weld in all positions. And 6G is another way of saying an all-position weld. And then I'm going to weld on a particular pipe, because pipe is harder to weld than plate. So I'm going to send my guy to weld on pipe. If he puts the weld on pipe, he's automatically qualified to weld on plate. And as for the diameter and the thickness, what I normally do is I qualify a welder to 1/2 to 2 times. So if I qualify an NPS 4, I can weld on NPS 2 pipe. And I can also weld on NPS 8 pipe. And if I qualifying Schedule 80 pipe, whatever that thickness is, I can weld down to half that thickness into 2 times that thickness. So instead of having all of these micro licenses, and welders might have little micro licenses for welding exotic materials and things like that. What welders do is they qualify to a very generic, very broad procedure, which is often just called an F3, F4 procedure, but I basically outlined what it is right now for you, an F3, F4 procedure, where they would use no backing. They're going to weld on pipe. They're going to put an F3 root with 60-10 rod, and then they're going to use a 70-18 for the fill and cap. And if it passes all the bend tests and all that kind of stuff, then the welder is qualified to do that kind of stuff. We're going to delve more into this. If you're following along, you want to skip ahead to Objective 8 because this is covered kind of superficially in Objective 8 in your welding chapter.